Welcome class. So today we're going to talk about intensity. Now, not the intensity of this weightlifter, even though he looks like he's under a lot of pain here and is quite an intense person. We're going to talk about maybe the intensity of the sound that's coming out of this weightlifter's voice and the sound that's coming out emanating from their mouth. So when we talk about sound intensity, we're just going to go over a definition first of all. We define it as the power over area. So the power produced by a sound, or the power of a sound over area. Now we also know from previous energy workings that power, we can rewrite that as energy divided by time. So, in fact, we have another way of looking at intensity. It is the rate of energy for a given area. So, the amount of energy in a given area. So, if we look at the diagram on the left, we'll see that we have a megaphone. And this megaphone here is releasing sound, which was shown by the blue arrows. And that sound, the intensity of that sound can be picked up at various different areas. And we'll see that the sound goes out in all directions, actually in a spherical direction, in all directions from the megaphone. And if we placed a receiver or a meter a certain distance from the source point, we would see certain things. Well, we would see that we could get a calculation for the intensity. And it might give us an intensity value of 1 by 10 to the negative 7 watts per meter squared. Remember, it's power over area, that's why it's watts per meter squared. And you'll probably notice that's quite a small value, which is the norm for intensity values. Now, what would happen if we actually took that meter and moved it further away from the point source? So as we move the meter further away from the point source and follow this green arrow, we know that the intensity, the energy picked up by that sound would decrease. And now it is important to note that the power of the sound is fixed. But of course the area now, or how far that meter is from the sound source, has changed. And the area affects the intensity inversely. In fact, the intensity can be written as intensity is equal to power over area, and we write that area as the area of a sphere. We'll talk a little bit more in class about why that is. So it may look something like this, a little bit further out. If the meter was out around this point here now, it's going to give a different value, and that value might be 1 by 10 to the negative 11. So we can see that the intensity of it has decreased. So humans are equipped with very sensitive ears, capable of detecting sound waves of intensity as low as 1 by 10 to the negative 12 watts per meter squared. We've got amazing ears. And that low level of intensity is called the threshold of hearing. It's an important value. It is a threshold value, which means it's the lowest intensity value in general that humans are able to hear, or human ears are able to pick up. The most intense sound which our ears can safely detect is more than 1 billion times more intense than this bottom value. In fact, it is 1 by 10 to the 12 times. So let's do that in 6. So it is 1 trillion times more intense. So how in the level of intensity and the scale of intensity that our ears can pick up is a very, very wide scale, which goes from this bottom value here to top value here. Now this is, as I said, a very wide scale, which has a huge amount of numbers and values. So it would be nice if we had a way of making this scale smaller, of crushing this scale into values and numbers that we like dealing with. So enter the logarithmic scale. So the logarithmic scale takes these values and it basically takes this wide scale and starts crushing the wide scale mathematically into a smaller scale of values using numbers that we like to use, we're more familiar with. And this scale is a scale of perceived loudness, how loud we perceive certain sounds, and it is known as the decibel scale. The decibel scale uses logarithms to make those wide range of values into a smaller range. So how does it does that, and what are logarithms, I hear you ask? Well, if you haven't encountered logarithms in mathematics, logarithms, simply put, are the reverse operation of exponents. So hopefully you will have talked about exponents, and you know that there's various different exponents. For example, we could have 10 to the something, which would be an exponent value, 10 to the 1, 10 to the 2. The corresponding logarithm of that is called log to the base 10. We could also talk about 2 to the something, 2 to the 2, 2 to the 3, 2 to the 4. That's one that would be used in computing, for example, quite a bit. And the corresponding log of that is log base 2. Another example of a very typical exponent is e to the something. E is a specific value like pi is, and that's something that's used in calculus quite a bit. Actually, it's used in a lot of different things, and the corresponding log value, that is log to the base e. So let's have a look at what that might look like just using some numbers. So if we look at exponents of 10 and we ask ourselves, what is the exponent value of 10 to the 1? So 10 to the 1 gives us 10. 10 to the 2 gives us 100. 10 to the 3 gives us 1,000. And likewise, we can go the opposite direction. 10 to the negative 1, 0.1. 10 to the negative 2, 0.01. So we know when we write that out that we can get from the exponent to our final value. Well, logarithms, just like division is the opposite of multiplication, logarithms are the opposite of exponents. So if we start and we say, what is the log to the base 10 of 100? What we're actually asking is, what exponent value did we use on 10 to get to 100? And it would be 2. What exponent value did we use on the base 10 to get to 1,000? It would be 3. If we wanted to get, what would the value be for exponent value did we use on 10 to reach 0.001? Just let you think about that for a couple of seconds. Okay, if you actually said negative 3, you're correct. So 10 to the negative 3 in terms of exponents gives us 0.001. So the reverse of that is, if we take the log to the base 10 of 0.001, we get negative 3. So let's have a look at that in a little bit more detail. So the question that we asked was, how many tens, that we could ask ourselves, how many tens do we need to multiply to get 100? Well, if we look at this setup, 10 to the 10, which is 10 times 2, gives us 100. So if we change that and we look at log values, so the log of your final answer, if you like, which is 100, and our base value is going to be 10. It's always going to be 10 for decibels and intensity. So log of 100 to the base 10, that value is 2. So that is the exponent value that you began with. Let's look at another one. If we say 1 over 10 times 10, that's equal to 10 to the negative 2. We know that in terms of exponents, hopefully. And so if we are to, and that is 0 0.01. So 10 to the negative 2 equates to 0.01. Now if we start this in terms of logs and we want to figure out, you know, what value have we got in terms of logs, or how do we write that? We start with our main value. So what would be the main value that we ended up with? If we wanted to find log of 0.01, we ask ourselves, what is the base value? Well, it was 10. And so what we're asking then is, what did we multiply, what exponent did we raise 10 to get 0.01? And our answer, of course, is -2. So you can see that the logs actually take these very wide-ranging values and put them down into small values, 1, 2, 3, 4, -1, -2, and so on. So how do we relate this to intensity and the decibel scale? Well, intensity and the decibel scale are connected, but the decibel scale is a scale measuring human reaction to intensity. Or another way to write this would be loudness. So the decibel scale talks about loudness, and it is putting our perception into the scale. So the decibel scale does use logarithms, and it is also a ratio of intensity measured against the bottom intensity that the ear can pick up, called the threshold of hearing. And that threshold of hearing value is assigned a value of 0 dB. All other or intensities, or intensity values, are measured as a ratio against that bottom value and rewritten using a logarithmic value. And we get what are called decibels. So when we're writing this in terms of an equation, the decibels, the bells are set up using this ratio value, and the ratio value is your intensity against your base intensity, written as a ratio. We are then going to log that to the base 10, and we do something a little bit weird at this point. We actually don't use bells. Why? I have no idea. We use something called decibels. And we must multiply our answer by 10. I guess it makes our answers a little bit better in terms of the final number. So decibel, an equation for decibels is written as dB is equal to 10 log I over I0. And this is what we're going to use to calculate certain decibels readings and move from intensity to decibel scale, and vice versa. So just to give you a final example, what decibel reading is used for an intensity value of 1 multiplied by 10 to the -9 watts per meter squared? So we have an intensity value, and we want to know if you had a meter on your smartphone or a device that could pick up decibels, how would that look in terms of decibel reading? So we start with our equation, decibel is equal to 10 log. We firstly write our intensities as a ratio. So this is our given intensity, if you like, 10 to the -9, and this is our I0 value. And that is 10 to the -12. When we rewrite this ratio value, we put it into a calculator. You'll see that in this instance, that ratio value gives us 1,000. When we then take the log to the base 10 of 1,000, I'm just going to give you a couple of seconds to see, can you figure out what would log to the base 10 of 1,000 be? Okay, if you said that value was 3, you're absolutely correct. So all of this portion here in blue is that value comes out as 3. And so when we multiply 10 multiplied by 3, because we have that 10 sitting there for decibels, remember, we get a decibel value of 30 dB. So you can see that it is a far easier way of writing it rather than 1 by 10 to the -9. And it also is a nice way of crushing that range for intensity readings. There are other types of questions that we can ask on this as well, and we'll get to doing more of those in class.